In this video, we are looking at arithmetic series, and arithmetic series is the sum of the terms from arithmetic sequence. For example, this one. We are going to see how we can derive a formula for a finite number of arithmetic series. So we consider this sequence given here, and I'm going to find the sum of the first 20 terms, because this is what I'm given here. And then using that idea, I'll come up with a formula for getting the sum of n terms, a general formula. So I'll take 2 and I'll add 4, add 6, add all the way to 38 and up to 40. And then I'll start from the other side, 40 plus 38 plus 36, and I'll keep adding all the way to, this is going to be 4 plus 2. When I divide, this becomes 42, 42,
What?
and then 42 plus 42. See, I'm getting 42 every time. So from what I see here, because I'm getting the same number, I can take 42, I multiply it by 20, because I have 20 terms, then I divide by 2, because I added 2 rows instead of 1. And this is going to give me 420. So that's how I can be able to do it quickly. So how, using this idea, how can I come up with a formula? So if I need to find the sum of the first n terms, the formula for n terms can be given by the first term plus last term, then I divide by 2, and then I'm going to multiply by how many terms I have, so times n. Okay, so the formula here, let me simplify this formula. This formula is equals to n over 2, and then the first term plus the last term plus the last term. So that's the formula right there. See, this formula, since I know that, how else can I write this formula? I know that the nth term is given by the first term plus n minus 1 times d. So what I can do, I'm going to write this formula here. So as n is equals to n over 2, and then I'm going to write the first term, instead of a subscript n, or the nth term, I'm going to plug in this formula plus the first term plus n minus 1 d. And then if I simplify this, it will give me n over 2, and this is going to be 2a plus n minus 1 d. So this is the sum of the first n terms. So that's the formula there, and this is an alternative formula to use. So depending on the situation. So here we are told to find the sum of the first 15 terms of the sequence. So let me write what I know. I know the first term is 25. I know that n is equals to 15, and I also know d is equals to -2. So since I don't know the last term, I'm going to use this formula. So that is 2a plus n minus 1 times d. So I just need to plug in what I know. So this is going to be 15 over 2. 2 times a is going to be 50 plus, it's going to be 50 plus n minus 1. So 15 minus 1. And then I'm going to be multiplying that by minus 2. So this will be 15 over 2. And this is 50 minus, this is 14 times negative 2. So this is going to be times 22. So this is going to be 165. That's the answer. Let's do another one here. Find the sum of the sequence. So this one, I don't know how many terms, but I am given the last term. So I'm going to say here, but one thing I can tell is the first term, which is 5. I also know D is 4. I'm adding 4. So to find the sum of 15, to find the sum, to find n, or how many terms to get to 61, I'm going to find, to say 61 is equals to the first term plus n minus times d, and then I'll plug in what I know so that I can be able to find n. So this is the first term, which is 5 plus n minus 1 times d, which is 4, is equals to 61. And that means this will be 4n minus 4, 5 plus 4n minus 4, which is equals to, this is going to be 4n plus 1 is equals to 61. So n is equals to 15. So n is equals to 15. So I'm looking for the sum of the first 15 terms. So now I can use the formula for the first. So n over 2, the first term plus the last term. So which is going to be 15 over 2, the first term, which is 5, plus the last term, which is equals to, this is going to give me, when I multiply this together, so this is going to be 66. I divide by 2, that is 3 times 15. So this is going to be 495. So here, we are going to use this sigma notation to denote a series. So this sigma notation simply means we are going to plug in 1 to 6 in this sequence, in this formula for the nth term, and then add the terms. So when I plug in the first term, I'm going to get, when I plug in 1, I'll get 11. Then I'll say plus, because it's sigma, then 12. I add, that's when I add 2, I add 3, I get 13. I add 4, I add 5, I add 6. 1, 2, 3, 4, 5, 6. So that's the formula. So we look at this one. I'm plugging in 1. So this is going to be 2 plus 1. So I get 3. So I add, then I'm going to add 2. So that's going to be, so the next one is going to be, when I add 4, this is going to be 5. Then I'm going to add 3, so this is going to be 7. Then when I add the next number, I'll get 9 and then 11. So that's how the sequence is going to be. Remember, it is finite, it stops at 5. It doesn't keep going. Okay, here I need to find the sum. So what do I know? I need to write the first term. So the first term, I get it by plugging in 1. So it's going to be 7. I also know the last term, or I can be able to get the last term, which is equal to, the last term is going to be, I plug in 300, which is going to give me, so this is going to be a 300, which is going to give me 605. So I'm looking for the 300 terms. So I'm going to use the formula n over 2, so 300 over 2, and then the first term is 7 plus, and then the last term is 605. So when we work this out, we're going to get that number. Okay, let's do the other one here. Again, I'm going to find the first term. So I plug in 1 into the series, I get 8. I plug in 20. Then I get 103. And then I need the sum of the 20 terms. It's going to be n, so 20 over 2. And this, then I take the first term, which is 8, plus the last term. And then when I do all this, I should get that number. And just maybe to mention, this is the formula I'm using. When I'm given the sequence, I'm using n over 2. So the first term plus the last term